Hey everybody, my name is Keith Moore, CEO of AutoScheduler. I wanted to present a three-part series to all of you, specifically on an introduction to artificial intelligence, some applications of AI in supply chain and manufacturing. And then I also wanted to give you some practical tips on how to actually implement AI inside of your organization. The intent here is to get rid of a lot of the BS. There's a lot of buzzwords, there's a lot that goes around social media on how AI can actually apply to your daily life. My hope is you leave this session and this three-part series with a very good understanding of what it is, how you can apply it, and how to actually get started. So with that, let's go ahead and dive in. Let's start on what is artificial intelligence. I'm going to give you the Keith Moore definition. This isn't really something that you're going to get in Encyclopedia Britannica, but my definition and the simplest way to think about it is AI is math plus data plus computing power. It is our ability, so artificial intelligence is our ability to take mathematics and advanced mathematics and algorithms, combine that with existing data, and that is our data that we own, data that is available to us, and computing power. So some CPU, GPU cycles that can actually run that data through different types of mathematics to produce some measure of outcome. And there are all sorts of different types of outcomes we care about, but we're going to make this really practical for you guys moving forward. One piece of advice that I would give to people is AI seems so nebulous. And so the advice I give is if you replace the word AI with math in any sentence, does it sound stupid? And if the answer is yes, you need to be a little bit more specific, right? I'm going to change my life with AI. If you were to say, I'm going to change my life with mathematics, all of a sudden this is nonsensical. And so you want to be very specific in how it applies. Exactly the same here. Replace AI with math and things will start to make sense. So what are the types of AI that we are talking about? I like to break it into two separate groups. The first is intelligence. The second is action. So AI designed for intelligence is designed to help us learn and predict what is going to happen. There are all sorts of algorithms that actually help us do that, but they help us understand the data that we are looking at, either describe current state or predict future state. They inform us on what that data means. The second type of AI is going to be action-oriented AI. This is AI that actually helps drive decisions and a pool of optimization, reinforcement learning, different types of algorithms that not only take data, but also input semantics, so context, for example, and then help us decide what is the action that we should actually take in order to move forward with whatever project it is that we're working on. So given all of this, what is machine learning? Machine learning is something that you hear a lot about, but it means a lot of different things. So I'll make this very simple in saying machine learning is a subset of algorithms, an algorithm being something that applies math to data, that focuses on finding patterns in that data. And I have this fun little graphic to describe it, which is data by itself doesn't drive any value. When you start to categorize that data, you can view it as information that you can then sift through. Once you can piece that information together, you start to build knowledge on top of it on what is the current state, what is happening. When you take that knowledge and you can tie specific causes to effects, you start to have insight into what the data is telling you. When you're able to map exactly how things traverse through that information, you're able to understand, well, I'm wise enough to gain these insights consistently. And really what it then eventually comes down to is what is the data and what are the key drivers that hit the impact that we care about as a business or as a project. So machine learning, simply another fancy way of saying this is a series of algorithms or mathematics that can be applied to this data to generate impact. So then, Keith, what's deep learning? Deep learning has been around since the 60s. It just wasn't always computationally feasible. So deep learning, a term you hear very often, is a subset of machine learning, meaning is a type of algorithm. And this is actually something that is known as a neural network, or originally it was a multi-layer perceptron, MLP. And deep learning is a type of algorithm that is designed to mimic the human brain. If you think of the human brain, we have all sorts of neurons, little brain cells, connected by synapses, so things that actually fire at different intervals. So neural networks are really large representations of that in mathematics to take in data and output types of results. And they were transformative to the industry because not only can you predict things with them, but neural networks are what are used for image detection, right? If you're using facial recognition technology, more often than not is using it. If you're able to take a picture with your iPhone and it says, would you like me to tell you what kind of dog this is, right? That is neural networks working in the background, using that information to create results. This is just a subset of deep learning. Deep learning is a subset of machine learning, so it's nothing really that crazy, fancy, or hard to understand. So let's shift gears a little bit and talk about action-oriented AI. So things that actually help us drive decisions. And one of the most common technologies that enables us to do this is known as optimization. So optimization is something that says, given I have all of this data and these constraints, a constraint being when I am driving to work, I can never go over the speed limit, right? I can never go higher than 70 miles an hour on the highway, or 85 if you're in Texas like me in some particular highways. And so it takes the input data of what I'm trying to do, the objective, overall outcome I'm hoping to achieve, the constraints, and then it runs through all of these different options to tell me this is the right way for me to get where I want to go if I'm driving to work. So a really good example of an optimization algorithm that everybody's familiar with is if you use Google Maps or Waze or Apple Maps, for the crazy people out there, it will actually tell you, it's sitting in my car and it says, I know where I'm trying to go, drive for 2 miles and then turn right on this road. It has already mapped through the known universe and said, this is the best way for me to get where I want to go in the most efficient way, because it's optimizing not just for time, or not just for getting there, but also time and distance. So that is optimization. So we've covered this kind of suite of algorithms and words that you hear in AI. Let's talk a little bit about some of the more common technologies that people are talking about today. So this is generative AI. What is generative AI? Why is everybody so caught up in it? So generative AI leverages a technology called large language models. Not just language models, but large language models. And this is important because these are very specific types of neural networks, which we've already discovered is neural network deep learning models. And they have taken what is effectively the known internet and trained neural networks on the internet such that I can input text and it will actually generate text that makes sense in response to whatever my input is. So you're familiar with, there are major vendors that are doing this, from ChatGPT or OpenAI, Google with Gemini, Anthropic with Claude. DeepSeek was one out of China that created quite some waves about a year ago, and how they were able to do it much more efficiently than most of the other large language model manufacturers. But this technology is transformative in how we live our everyday lives, how we develop technology primarily in software, and how quickly we can scale what we as people do in everyday operations. And so there's a lot that is scary as it comes to this. There's a lot of people worried about their jobs. A lot of those concerns are very legitimate. And we'll talk through the overall power of these models and what's so cool about them as we go. So to do that, I want to tell you a story. This is my dog. His name is Murray. And so I've been very plugged into the space for a long time. I was one of the early users of ChatGPT from OpenAI. And one day Murray was sick at home and he was laying on the floor, and it was about 10 o'clock at night. My wife walked by and she said, "Hey, Keith, he doesn't seem to be doing well. Can you take him to the emergency vet?" And it's 10 o'clock at night. We've got kids in bed. I'm like, I think he's fine. He probably just ate something. He is just fine. So 20 minutes go by. She comes back and she's like, he still doesn't seem fine. Are you sure we shouldn't take him to the emergency vet? So she then says, will you please at least Google something, look something up to figure out if something's wrong with Murray. And so I'm sitting there Googling things nonstop. Dog laying on carpet, breathing hard, right? Everybody's been through this Google search tree before. Okay, well, that takes me down 100 different options. He doesn't have heart disease. He could have something else. Okay, I think he ate something. And the more specific you get, the worse the results got. So 30, 40 minutes in, I think to myself, well, I have this access to this ChatGPT thing. How about I try that out? Hey, ChatGPT, my dog isn't doing well. He's laying on the carpet. My wife thinks he needs to go to the emergency room, but I don't think he does. I think he's fine. Can you help me understand if I need to take him in or not? And It then led me through a series of questions like, hey, can you feel his paws? Are they warm or cold? They're cold. All right, well, look at his gums. What color are they? Are they pink? Are they white? They're pretty white. It's hard to tell because I don't look at his gums that often. Okay. It then asked me a series of 3 or 4 more questions. Feel his stomach, do these other things. And it ended with a string I'll never forget. And it said, you need to take your dog to the emergency room. This is a valid emergency. After going through all the, I am not a veterinarian, please call a veterinarian for advice and all of those things. And why this was so important was it had the exact context of the decision I needed to make. It helped walk me through at my level how I could actually receive that information to make a judgment. And it turned out to be right. So his spleen had ruptured. He was going to die in about an hour or 2 if we hadn't taken him in. We were able to get him in, get the emergency surgery done, and Murray lived, he was older at the time, but he lived for well over another year after this occurred, all thanks to me using this brand new technology to save his life. And so when you think about this type of technology in any application, right? This wasn't a model trained specifically on how to be a veterinarian. It was all of the power of the internet with context at my fingertips that I could steer to help me make better decisions. And that's only the tip of the iceberg of where we're going. That's how the world is changing with large language models. And so what you're starting to hear more about with LLMs is this concept of agentic AI, right? And this again seems big and scary. Is what are agents? How do they work? What does this mean? Realistically, what this means for everybody is an agent is going to be a large language model. So something that has all the context of the internet, has objectives or questions it's trying to answer, a mission that can interact with, but it also has agency. So the ability to not only observe, orient, and decide like it did in helping me understand what to do with Murray, but also act. So can it take in all this information? Can I provide some very seamless guardrails on decisions an agent can make? And can it then act on my behalf or a business's behalf to automate many of those functions in the context in a way that a person would? So agents in software are becoming much more prevalent to start to automate all of these different types of tasks, right? I know people that have agents writing software, agents reading their email and understanding how to prioritize things. I was asked by my board to get a secretary, and you can never replace an individual person, but I don't, I'm not busy enough for a secretary. I feel like my calendar's a nightmare enough as it is. I was able to build an agent to help me keep track of my day and guide me through my day. And I was able to do it in 30 minutes. So the world is getting to the point where agentic AI and the ability to start to automate tasks is no longer something for the 1% of the 1% of power users in technology. This is becoming very commonplace where anybody can actually go and start to build their own agents on the data they have. One caution I would have for people doing this is you are responsible for the output of your agent. So be very careful if you decide this is a technology you want to invest in, because at the end of the day, people have been arrested for decisions made by their agent under their bidding. So you have to be very disciplined in the guardrails you put into place in what you allow these systems to do, because they can very quickly get out of control or just misunderstand what you're asking for and make very poor decisions, much like interns or anybody else that you work with. So that's it for part 1 of understanding what is AI. For part 2, I'm actually going to walk you through practical applications of where it drives value and different areas that you could be using these types of artificial intelligence we talked about today in your life and in your business. Thanks. Have a great day.